Welcome. My name is Ron Papaschmidt, and I'm the creator of the Net Zero Now YouTube channel. This is going to be video 4A. It's going to be a foundational core video, and it's going to be the first one in the science section, where I'm going to give an overview of how Earth's climate systems operate. And I've titled this video, "This is Not the Center of the Universe," after another one of my favorite Eagles songs. So let's begin. Let me start with say that this is going to be sort of an overview video. I was really going to include this all. I was just going to create one overview video, but it just got way too long. So I decided to break it into 3 segments. And this is sort of what I would say is sort of an overview of how the universe sort of operates, where Earth fits into the universe. Now, I don't think there's any new information I'm providing anybody here. But I think it's just proper to maybe just like a refresher so as we start looking at Earth's climate systems, we sort of look at it and say, okay, we're not an isolated thing here. We're really part of an overall universe. And so I thought it would be helpful just to do this quick refresher video to sort of bring us all up to the same sort of level as we start looking at the additional science videos. And what I'm going to cover here is how Earth fits into the universe, what Earth's environment is like, some of the scientific laws that cover the universe, and basically what Earth's climate system looks like. And I explained just briefly now why I'm going to do this, is we are really just a minuscule part of the universe. And the universe does govern our physical laws. And so I thought it was just quickly important to do this, this overview thing. So let's begin. Here's the universe. Based on the knowledge we know right now, we think the universe has somewhere between 200 billion and 2 trillion galaxies. And most of those galaxies are somewhere between 3,000 to 300,000 light years in diameter. Now, all these numbers are just, I mean, it's basically impossible for us to comprehend, I think, just the massiveness of the galaxy in which we live in. And then most of those galaxies are millions of light years apart. I mean, so we have 2 trillion galaxies that are maybe up to 300,000 light years in diameter, and the galaxies are a million light years apart. I mean, just unbelievable. So when we think of light years, it's really hard for us to relate to that. So I thought maybe I'd just give you a quick example that might help here, you know. We were proud of ourselves as humans. In, I think, 2017, we just sort of finalized the calculations now. We were able to record the length of the largest lightning strike we've been able to record to date. And it covered 515 miles, and it did that in 7 seconds. So if you think of 7 seconds, let me see, that's just a sort of small part of a minute. And it covered 515 miles, right? So we're talking about, 3,000 to 300,000 light years. I mean, it's just hard for us to comprehend. So anyway, let's go on. Enough of that. So we happen to live in the Milky Way galaxy, and you can see on the upper left-hand corner here is a picture of the Milky Way galaxy. And you can see it's sort of a disk that with bulges in the center, and it's sort of warped. And the reason is because of the gravitational pull of other galaxies. Then over on the right-hand corner now, the Hubble telescope has been able to identify some of the stars within the Milky Way galaxy here. The Milky Way galaxy has somewhere between, they say now, I think 100 to 400 billion stars. Okay? And one of those stars happens to be the sun. So the sun is one of 100 to 400 billion stars. And then the Earth sort of rotates around the sun. Now, the Earth that we've been able to identify is about 25,000 light years from at the center of the Milky Way galaxy is this sort of supermassive black hole. We're about 25,000 light years from that. We're also about 25,000 light years from the edge. So let's maybe keep moving forward here. Now we're getting a little bit closer here. Now this is a telescopic from the satellites pictures of Earth. If you look at Earth, it's interesting. You see a lot of blue there, right, which sort of represents water. And you notice something, sort of all connected, okay? You can see the floor on the left-hand side, you can see the coast of Florida and the Gulf of Mexico or the Gulf of America or whatever we want to call it. But you can see that that's not a distinct body of water. It's really connected to the rest of the water around the planet, right? And just look at the cloud systems. You can see we don't have a cloud system of the United States and a cloud system of China and a cloud system of Russia and da-da-da. We have one cloud system that sort of captures the Earth, right? So we're all part of a global entity. And so if we're going to deal with climate science in Earth and what's happening here, we need to look at it from obviously a global perspective. Now, here's a little bit closer illustration of Earth on the left here. Here's just some fun facts of Earth. I mean, we think we're sort of static as we look at it, but here's what's really happening, okay? The Earth orbits around the sun at about 67,000 miles per hour. At the same time, it's on an axis that is it's spinning at 1,000 miles an hour, and we're in the Milky Way galaxy, which is moving at 1.3 million miles per hour, none of which we really have any sense of, okay? And then we have a climate system on Earth, and which you can see on the left-hand side there, where you can see the various different cells, the Hadley cell, the mid-latitude cells, the polar cells, you can see the equator or the intertropical convergence zone. You can see we have trade winds and westerlies, etc. All of that is influenced, and those wind patterns are influenced by the first three things we've talked about. But it's also influenced by the temperature differences that exist between the temperatures at the equator and the temperatures at the pole. And then it's also influenced by, if you take a look at the right-hand side, you see the picture of the sun, and you see that the Earth is tilted. And so because of that tilt, it also influences our seasons and how these various different weather patterns, or wind systems and other things that impact the weather on Earth sort of operate, okay? I just point this out these are massive systems. They're part of a universe, and they're influenced by a whole bunch of things that it's not intuitively obvious to us. Now, on the bottom, on the right-hand side, I've done two videos now that talk about atmospheric circulation in some detail. And so if you'll take a look at those particular videos, if you really want more information in terms of how the Earth's circulation really works, okay? The other thing I want to point out, in the universe, God created this universe, at least that's what I believe. But there are certain governing laws that are used to sort of how the universe operates. Now, the human beings, we've done a great job. We discovered a bunch of things, and you can see some of them in the upper left-hand corner, upper right-hand corner, rather. These are some of the major discoveries that we've made so far as a human race, okay? And we're still a lot more to uncover yet. I thought I would also show in the upper left-hand corner the periodic table of elements. We believe those elements exist on all planets within the universe to the best of our knowledge, okay? So there's sort of a universality to the universe, not just Earth, okay? And then we have, I thought I would list some greenhouse gas molecules here and their structure. And point out that those molecules, we believe operate the same way on other planets within the universe. Okay, these are not unique laws that apply to Earth. And the way they work and interact with the sun and other things is how we get greenhouse gases, how we get why our temperatures are rising, rather, I should say. And we talked about that in other videos, so I'm not going to go over that here now. And then the other thing I want to point out is that we discover within inside these molecules now, there's a lot more information. So on the graph on the lower left, it starts with matter and says matter is made up of molecules. But we've come to discover that it's not just molecules. Molecules are made up of atoms and electrons, etc. And then there are nuclei, and then there are protons and neutrons, and now those protons have charges, and now we have quarks and all kinds of things. So what it seems to be a really simple molecule is a lot going on there. It's a very, very dynamic environment, okay? And it's one that we need to respect. So we're going to talk about now Earth's climate systems as we in this science section. And I just want to say that Earth's climate system really is composed of 5 major spheres. The atmosphere, which is air, the hydrosphere, which is water, the cryosphere, which is ice, the lithosphere, which is the crust in the lower layers of the Earth, and then the biosphere, which is living things, okay? And they all interact with one another, and are all governed by the laws and things we've discussed in earlier sections of this presentation. So let's wrap this up. Again, I don't think there's any new information here. But I think it's important, as we look at climate, that we understand, as the eagle said, is that, this is not the center of the universe. Okay, Earth isn't determining the way the rest of the universe works. The universe determines how Earth operates. And it is massive, as we can see. And it's very complex, and it's incredibly dynamic, which we really, I don't think, appreciate a lot. If you go outside, let's say about 8 o'clock at night or something like that, you look up in the sky, you can maybe say, well, the sun's sort of setting, you can see sort of a moon, so you get some sense that there's some motion there. Let's say you're standing on my cement sidewalk or something, Sidewalk doesn't look like there's anything going on. It looks like a solid. Do you get a sense that the Earth is spinning and rotating, or we're part of the Milky Way galaxy that's moving at 1.3 million miles an hour? Of course not. Everything seems static to us, right? Our perceptions we just can't perceive what's really going on in the world that we live in. And so I think as we look at the science here, we need to just appreciate that fact. And as we understand more and more about how science operates, we need to understand we're not going to change that. That's the way God created it. And so we have to learn how to adapt and appreciate that and work with it if we're going to solve this problem. And so that's why I wanted to do this quick video here. And as usual, you'll see Eagle songs enter into a number of my themes. So here it is again. So let me just wrap this up now real quickly and say, what can you do? Well, one thing I'm going to talk about frequently is you need to vote. And then, subscribe to this channel would be very helpful. But if you have any questions or if there's subjects you want me to cover that I haven't covered already, please submit them in the comment section and we'll look at it. So thank you very much for listening to this video, and I hope you'll join us for the other videos as we start moving forward here.